So I'll quickly introduce myself. I'll introduce Aleo, and then I'll go into maybe some Q&A if people have some Q&A. But my background is primarily in the validator ecosystem, so infrastructure, as well as mining. So I used to be the head of protocols at Stakefish, which was at one point the largest non-custodial Ethereum validator. And we were the largest Cosmos Hub validator. And I also led special projects at F2 Pool, which had been the largest Bitcoin mining pool at one time. Those two pieces of information are I think, pretty important because of what we would call the sort of hybrid infrastructure class setup that we have at Aleo. And one fun fact is, so Aleo was, and we'll get to some pictures later, but Aleo was a manifestation of a paper that was written in 2018 called Zero Knowledge Execution, which basically allowed privacy and programmability. And there's a slide actually that will go into sort of the evolution of how that has happened. But one of the co-authors of that paper called Zexy was Matthew Green, who was my graduate school advisor when I was studying cryptography with him. And Matt Green was also one of the co-authors to a privacy blockchain called Zcash. And Ian Myers was another one of my professors who was also the co-author of the Zcash white paper called ZeroCoin. And both Matt Green and Ian Myers are both advising Aleo right now. So yeah, that's a little fun fact. I think most people are pretty aware of the need for privacy in these blockchain environments. I think one pretty core part of maybe the limitations of cryptocurrencies and their private blockchains has been around the inability for us to use it in a mass scale. I think if probably most of you here have used a blockchain like Ethereum to either send someone money or buy something, the reality is that it's a horribly both computationally inefficient way of making transactions publicly, and also the moment that I send my friend some money on Ethereum or a public and transparent blockchain, you know exactly how much money I have if you don't have multiple wallets. And so, right, this is kind of ties into a lot of the important sort of domains that people think are hot right now. Obviously, I had described finance, but then it also goes into some critical topics that Aleo specifically and many other privacy projects use zero knowledge proofs as a way of protecting that privacy. And that aids in identity, gaming solutions, and then let's say pre-steps to what's helpful for ML. And then also, if for those of you, I know this is a privacy event, but for those of you who don't know what zero knowledge is basically something what we would call like zero knowledge proofs. It allows you to attest something without revealing the contents to it. So I know people use that exact phrase a lot, but a good analogy for how ZK or zero knowledge can be used is, let's say you're trying to solve a calculus problem, and you want to prove to your friend that you know how to solve the calculus problem, right? And so you can like enter in that calculus problem into, let's say, an online solver like Wolfram Alpha or something. You put it in and say, give me the derivation, and then out comes the derived result. Maybe let's say you actually input something and you get a number, but all the steps in between that shows how you got to that end derivation are not revealed. And so it's basically that part of proving that you were able to solve the solution correctly in a verifiable way. And one really key component of ZK that we have, which a lot of other blockchains that don't necessarily use ZK for privacy, but rather scalability uses, is that it's quite hard and time consuming and computationally intensive to generate these proofs of attestation, but it's very, very easy to do the verification itself. So those are pretty important concepts as you're kind of listening along. But yeah, I mean, at one point, ZK has been around since like the 1970s, 1980s. And then I think there were some FHE people here too, right? Which many consider to be the holy grail, but right, ZK is like sometimes can be a really important component into FHE. And I can tell you a fun story around that too. So basically the TLDR for kind of this slide, or the purpose of this slide of what we would say like real world use cases, is that, right, I don't think anyone has this default assumption that, right, when I want to see the future of banking or the future of finance, that everyone in the world can see exactly how much money I have when I send it, but rather I would like to have private payments. And a key part to this private payments concept specifically, because we had private payments with Zcash and Monero or Grin, if you guys remember those, but then it's private payments with programmability, right? Because Zcash did not necessarily have the type of programmability that Ethereum had, right? And we can go into, right, sort of, I don't know if this is large enough, but I'll just describe this slide of, right, the functionality and the technology that we had in terms of a decentralized and adversarial network was, right, like you needed to have transparency for people to, right, trust each other without obviously giving trust. So what I mean by that is, right, crypto and the blockchain world for a long time used to rely on this mantra called "don't trust, verify," where everyone was proud of like being in this open source environment where we'd have all these public blockchains, public nodes, you can re-execute things if you want. And then only once you've done that yourself, you would trust a smart contract or execute something. The problem is I don't know if you guys will answer, but I mean, how many of you guys have actually looked at a smart contract yourself before buying an NFT or participating in a decentralized exchange, right? Like, you guys can raise your hand if you're devs, but like literally none of you guys raise your hands, right? None of you have checked the code yourself. This public, transparent blockchain that relied on this mantra of don't trust, verify, completely failed. And don't get me wrong, I do love and I use Ethereum a lot, and I develop on it. But the reality is that the core sort of like idealistic vision of you wanting to use this transparent blockchain because that's the only way that you can make sure things are done in an adversarial environment, none of you guys use it. None of you guys are using Ethereum or these transparent blockchains as you were supposed to. I don't think many of you have 50 or 30 wallets or different addresses, right? There's one seed phrase that you guys obviously use, but likely most of the world, not just you guys, are just using one account from one seed phrase. The reality is that the seed phrase that you have, the 12 words or 24 words that you have, you can generate almost a limitless number of accounts. Because, right, one of the components of these seed phrases and the accounts that you can generate is you have many different accounts that hopefully are not linked together, so that you can have this level of variable privacy when you are transacting in a public environment. But that didn't happen. And the limitations of the technology was that programmability aspect with the privacy or the lack of privacy got us certain things. So I mean, I don't think you can see too much, but basically, right, in the very beginning, we had Bitcoin, which, right, this was the ability to have commoditized hardware and infrastructure that allowed basically infrastructure providers to operate in a trustless and adversarial environment, aka right, if you knock one computer down or node down, then it'll still survive. And so once we kind of established this really great concept, which is what we had with through proof of work of sort of this crypto economic security, we now had programmability on top of it, right? And I'm sure most of you have heard that story of Vitalik being pissed off that Bitcoin did not have this programmability, and he was experimenting with colored coins. And then he finished, writing his Bitcoin magazine, and then launched Ethereum. And so with programmability, you had like this really important concept of, right, this composability layer, but that required trustless assumptions in a transparent manner. And then with this programmability came, okay, can we make it private? Which did happen with Zcash, with what Matt Green, Ian Myers, and others had launched. But then now we had, right, privacy, but not the level of programmability that a lot of public blockchains had, which, right, would not be the ultimate ideal form of what we expect a financial and technological platform to be. And so now we have, right, these attempts at privacy blockchains, what we call ZKL1s, and also what you can imagine as like these scaling solutions that also sometimes offer privacy, like ZKL2s, that give you what you want, right? Private programmability. And I think the purpose of this slide is to basically indicate, right, it's not necessarily discrediting any past projects, but it's the evolution of what we were capable of doing, right? Obviously, we moved into a proof of stake environment that is on the opposite end of the commoditized to specialized spectrum, and that has its own host of problems and solutions, but that's another topic. But basically, right, time has evolved, time has gone on, the technology has evolved, and then there's a lot of critical components that we have now been able to put together, which is what happened in the Zexi paper, Zero Knowledge Execution, that one of the co-authors, Howard Wu, had left his program at Berkeley, and then called it Aleo. This is just another slide of another way of looking at like the type of programmability versus commoditized hardware and programmability and privacy. And then now Aleo is one of, I'm sure there's many other blockchains that also are attempting to solve this problem of what should have happened for transactions in private and programmability. So one more thing, and the reason why this we say Aleo ZK by design is that privacy is defaulted. So if for those of you who are familiar with Zcash, you have this concept of public and private transactions, or you can say shielded or unshielded. Zcash has unshielded transactions by default. So default transaction type is all public. Whereas if you want to have a private transaction, you have to actually pay a little bit more money and then shield it. So Aleo is actually actually the reverse of that, where all transactions are by default private. But then you can also, the concept is you can wrap it and then it'll be public. But there's also important, and with many of these privacy projects, you have the ability still to reveal the contents of those transactions. And not to get too technical, but right, just like how Zcash has this concept of a view key or a graph key, Aleo does as well, right? And the reason that I mentioned that is because whether we like it or not, as much as all of us want to, burn down all the banks or, have this technology replace everything, their compliance and regulation is a pretty critical component to how blockchains can complement the traditional world of what we expect as mass adoption. And so even though there's privacy by design or privacy by default, you still do have the ability to be compliant by, let's use an example. Let's say you are suspected of laundering North Korean funds, and the Korean regulators come to you and say, hey, prove to us that your addresses on this privacy blockchain are not laundering North Korean funds. You can basically use a view key to reveal all your past transaction history. So the difference between that, right, that basically proof or proof that you haven't done something wrong is a one-on-one interaction, right? It's you versus or working with someone. You live in Korea, so you have to obey Korean laws. You working with in a lawful way, versus a public blockchain. They don't need to ask you that, which is fine. But then all your transaction history is traced, right? So, as pseudo-anonymous as you might like to think that your activities are, right? Whatever the Korean regulators or the financial regulators in North America, whatever, they all know essentially, or have the ability to trivially, know if who you've interacted with, right? I think it's a unspoken reality that, right, like TRM, Chainalysis, Elliptic, they have the ability to easily just take away, right, look you up and then see what transactions you've done and who you've done. And actually, fun fact is they'll actually look up to 3 to 4 hops or 3 to 4 different wallets that your funds have moved through. So, but yeah, so basically, the TLDR for this is that privacy is default. There's still the ability to have this compliance element through view keys, but some would say, and then obviously the designers of Aleo and other privacy blockchains that have a similar construct would basically say this is preferable because you're not revealing all your transaction history to everyone by default. Okay, but you can do this one-on-one. So this is just a quick picture of some of the folks. So Alex, Aleo did a foundation split. So in preparation for mainnet, there's a foundation, there's a core engineering team. So Howard now there's Provable and Aleo Foundation. Howard's the CEO of Provable, the core engineering team, along with the co-founders Colin Shin and Raymond. And then Alex Pruden is the CEO, executive director of Aleo Foundation. And so Howard's a co-author of the Zexi paper. And then, Joanna was head of Optimism BD at one point. She's now the BD head of Aleo. Alex was A16Z partner, and he was a Green Beret, some fun military stuff. But yeah, they're all really great people to work with that I've had the opportunity to do so. And then, I think I've probably gone over this for you guys, but you have this sort of intersection of all these components that are quite important that we haven't necessarily had the opportunity to see. I don't think you really see the intersection, but you have permissionlessness, right? You have a decentralized validator set and contracts, and then you have programmability that is able to provide privacy there. I know I only have a few more minutes left, but one other important slide is this. And there's this concept that people have thrown around for a lot of ZK projects is this concept of unlimited runtime. And so this is basically, it can be a pretty defining difference between public blockchains and private blockchains. So public blockchains do exist, and the way that they are able to provide this type of assurance in consensus or how the network agrees, the decentralized set of operators, is that every single node is re-executing transactions. So everyone is providing, one execution, and then you have tens of thousands of different nodes that are re-executing it, because that is by design. Versus, right, you don't have to have this, what we would call like miscellaneous execution happening, but it happens, right, what we would say off-chain, right? You can generate these proofs, and then the proofs themselves have the ability to, as I explained in the beginning of this talk, to attest to their veracity or their truthfulness. There is basically this movement of trust, essentially. As ironic as it sounds, like we have to trust in these trust systems, right? You have to trust the math, right? And that is another burden of like how we've moved away from this mantra of don't trust, verify. The reality is as I asked you guys in the beginning, none of you have actually verified yourselves. But then right now you also have to trust the math, and then hopefully we have the ability to make sure that the guys who do know these proofs can't do so. But to be honest, and I'm not saying that we're kind of giving up that sort of like, oh wait, okay, we have to trust a bunch of these nerds or these cryptographers to make sure that we're watching out for them. But the reality is that there is like a robust way of doing that. Very famous example is like the Clipper chip, right? Like there's this example where the NSA in America had attempted to basically hard code backdoors into every single credit card in America. And there was also another example of the NSA making sure that they had the computational expertise and resources to basically brute force certain encryption standards that the National Institutes of Standards and Technology had provided. But, right, there were basically these like watchdogs or whistleblowers, one of my grad school advisor being one of them, Matt Green, where they basically, right, were responsible for calling this out. Maybe like an analogy could be how, optimistic rollups have this sort of fraud detection period for a week, right? You have this ability where if it breaks, that fundamental trust in this math is going to be done. Okay. So I think, right, you have privacy, programmability, permissionless, and then you also have this sort of unlimited runtime concept that I think is fascinating about Aleo. One last thing I'll say that's interesting is, and then the reason why I explain my background of both being, working in the POW and the POS space is that Aleo's consensus is proof of stake based. Block building is done by validators. But then there is a POW component, which many would be familiar with calling just as miners, but we call them ZK miners, where they basically are solving Coinbase puzzles to generate rewards that then get included into blocks. And the really probably important part of that added POW style element, plus the consensus and block building for POS, is that ZK, and then there's one slide here, is that ZK technology is so dependent on the type of hardware. And then we've seen that with how ASICs have evolved for POW mining, probably like Filecoin, Bitcoin, etc. And so the POW concept revolves around this idea of good behavior is incentivized. And this good behavior in the Bitcoin and POW world was defined basically as, right, making sure there is this sort of re-execution and trust in the system, or trusting that the system is going to make sure that only good behavior is rewarded. And so the miners get paid. And so now we have companies like Bitmain that exist that, right, make all these ASICs. The same can happen with ZK, where ZK technology needs to rely on hardware, and hardware costs have been going down and the efficiency has been going up, where companies or layer one blockchains like Aleo or other privacy projects that use ZK that incentivize ZK hardware to be developed, we're going to get faster and more efficient and cost efficient hardware to have computation. And then this not only applied to privacy blockchains, but also many different real world use cases. And right, I used to do bioinformatics research for 5 years, and we used, right, ZK under the context of FHE for computing under encrypted data for like, gut bacteria data that we share between labs. And so, right, we're incentivizing hardware development through this sort of natively sort of win-win scenario of hardware manufacturers that develop better ZK hardware that will get incentivized, and they're able to pay for this R&D through like blockchains like this. And then now you have this touch point with the real world that's not just blockchain based, but the rest of the world. Okay, so I went over so much time, but is it Q&A or are we done? Yeah. Okay, all right. Thank you so much.